And welcome back to another edition of Flying with TFC. We're picking up right immediately after the previous video, the Sundiver mission. As you can see here, there's the fuel modules that I jettisoned at the end of the last episode. And now we'll hop back inside. And here we are. Here's our situation to recap. 37.54 meters per second current velocity. Altitude 30.16 astronomical units above the Sun. An astronomical unit being the mean distance of the Earth between the Earth and the Sun. So roughly 93 million miles, or I believe it's 1.5 million kilometers, I think something like that. We currently have a periapsis at the Sun of minus 587,000 kilometers, I think. Okay, and now I have to do the thing of figuring out what our fuel situation is. Just bring up the payload. Actually, I don't need that. Alright, where's the calculator? Okay, we have, let's see, 1, 2, 3, 4 of them that's full, 5 full ones, and a partial. So, the full ones contain 13,000 kilos of fuel, so 13,000 times 5 equals, clear the memory, store that in the memory. And then this one has 6576, and that's 6576 minus 4,000 for the weight of the container. So that's that plus the memory recall equals, our extra fuel mass is now 67576. So let's go ahead and get that updated. 67576. We now have 15.056 kilometers per second in delta V available. I'm going to go ahead and leave this burn time calculator up for the time being, because for this mission I can't see anything else that we would need to have up here. So, alright, now if we turn to ship prograde, put a time warp to make that faster, and bring up the planetarium mode. Alright, Saturn, Jupiter, there's the Sun off to our left. So I'm going to rotate the ship.
Rotation.
So that we are facing nose on to the Sun. Should be right about 270. And I've blown right on by it, haven't I? Yes. Okay. Alright, get this fixed. Saturn, Jupiter, Sun. There we go. Alright, now, to add insanity to craziness, we've got the ship oriented pointing at the Sun. We're going to accelerate towards it and speed things up, because our initial velocity is 37.5 meters per second. That's going to take a long time, even at 100,000x time warp. And so, kill rotation, and we burn full thrust. This will put the prograde velocity vector right on the Sun. actually. I'm going to burn a substantial amount of fuel doing this. We're accelerating our descent to the sun. So we'll continue burning here for a while. Periapsis is going down, so that's fine. And I think what I'm going to go for is leave myself about 10 kilometers per second worth of fuel. And then it'll begin the next time warp phase of this flight. Speaking of time warp, let's get a little 10x to get through this. It's interesting, the delta V number is counting up. That's interesting. It's probably because of the extra fuel mass and whatnot, but once those fuel modules are empty, that problem should stop. Okay, velocity 5 kilometers per second and accelerating. Okay, 9.9 kms per second left. Alright, first thing off, let's go ahead and jettison the empty fuel. Alright. Yes, they're all empty. So we'll just deploy these things.
Deploy, payload deploy, payload deploy, payload deploy, payload deployed.
Our LOX tanks are good. Our fuel payloads are empty. Right, clear that.
Information.
Close the doors.
APU running.
APU off. Now come back down here. And extra fuel mass, 0. We have 5.1 km per second of fuel remaining. That's okay. We won't need any for quite some time. Now, let's see. I'm going to target Uranus. That's the next point at which I will consider any mid-course corrections or anything like that. We are at 30.16 AU. Neptune or Uranus altitude is 19.79 astronomical units. And so now, kill rotation, and it's time to commence 100,000x time warp. And I'm going to check in as we cross the orbit of Uranus. Alright, here we are. We are about almost 11 years into the flight, which you can see here, 4,011 days on the mission elapsed time. The oxygen level, we still have over 10,000 days worth. And in fact, to my surprise actually, we haven't even emptied the first LOX module. So I might have been able to get away with just 3, given a single crewman. But that's alright. At this point, we're crossing the orbit of Neptune, 19.07 AU from the Sun. We have accelerated to 11.82 kilometers per second, just simply due to the Sun's gravity as we fall towards the Sun. At this point, I'm going to do a little bit of a course correction. Make sure we're prograde to start with. Okay, we are. And now I'm going to rotate outward. And we're going to do a slight correction burn to bring the sun periapsis up to a slightly positive number. So we'll rotate outward here to 90 degrees. And a bit of a burn to bring that sun periapsis to a just barely positive number. That's good right there. Now we'll just rotate back to prograde. Alright, now I'm going to change my targeting here. The next planet to reference is going to be Saturn. And the next check-in will be in another 10 astronomical units as we're crossing the orbit of Saturn. Meanwhile, I'm going back to 100,000 X time warp. Alright, here we are. We are now, let's see, 5,318 days, which works out to about 14 and a half years into the flight. The liquid oxygen supply still shows as being over 10,000 days worth. And we're about 80-some percent, 83.7% of our oxygen supply. And I checked a little while ago, and we haven't even still yet emptied the first LOX module, although it's getting down there. Oops, wrong direction. Okay, so now something occurred to me, because I've noticed that the periapsis is still trending further negative. Our velocity right now is up to 15.55 kilometers per second, and we are about 9.08 AU out from the sun as we cross the orbit of Saturn. Something occurred to me. We'll bring up interplanetary MFD and go to the map program. Let's see, turn off auto zoom, display that, and show SOI, and apparently I need to zoom out. Okay, the white dot is the ship's position, and this is the orbit of Saturn. And what I'm going to do on orbit MFD is I'm going to target Jupiter, because as I cross the orbit of Jupiter, that will be the next check-in point. But it's interesting to note, the Interplanetary's map program is known to be pretty accurate, and it's showing that the Sun PEA is going to be about 16.45 kilometers or 1,000 kilometers below the surface. So what I'm thinking to do here is, let's go ahead and rotate for another outward burn. And then do a burn specifically to bring this Sun PEA up to about 100,000 kilometer positive number. That's good right there, 99.8 thousand kilometers. And according to this, the periapsis velocity will be 577.5 kilometers per second. That is going to be interesting. So I'm going to follow this on IMFD's map program just because, well, just because. Meanwhile, go ahead and rotate back to prograde. resume time warp again. Although these time warp phases are getting shorter and shorter between them because the velocity keeps increasing. And it's going to be spectacular. We'll be back. Alright, we have the end of another time warp phase, not nearly as long as the last one, and I think they're going to get a lot shorter. Okay, we're crossing the orbit of Saturn, as you can see here on IMFD. This PEA prediction on IMFD is still holding at 99.93, whereas this one has been going down and up, and I think it's trending upward right now. Velocity 19.36 kilometers per second. And 5,691 days into the flight. That puts us about 15.5 years after launch. It is now January of 2030. And during this last phase, we finally burned through the first LOX module, so I'm going to go ahead and jettison that. Not that I suppose it matters a whole lot, but I want to.
Information. APU fuel 90%.
And we jettison that.
Payload deployed.
And I'm thinking at this point, I definitely could have done this with just 3 LOX modules. So what I'm going to do may be considered wasteful, but I'm going to go ahead and jettison 2 more full ones.
Payload deployed. Payload deployed.
So now we have 3 full LOX modules. Time warp a bit to let them drift free.
Information. APU running.
Close the bay doors. Alright, now let's check our oxygen situation. It still shows over 10,000 days worth. So I don't think there's any problem in having gotten rid of a couple of full ones. And now, given that periapsis is holding, I'm just going to change my target on orbit MFD to Mars. The next check-in will be as we cross the orbit of Mars, which shouldn't be too awfully long in real time. Let me zoom in on IMFD a little bit. Got a pretty good sized gap to cross, but we're going to be doing it probably better than 30 kilometers per second by the time we reach the orbit of Mars. At least that's my guess. Okay, let's kill rotate and resume time warp. And I'll check in a little while. All right. It's only been a few minutes this time, and we are already crossing the orbit of Mars. And so, okay, the next thing to do is to go ahead and target Earth as the next orbit to cross. We're currently going 33.21 kilometers per second. We are 250 billion meters above the Sun. I believe that's right. 250 gigameters, so 250,000 kilometers, or 250 million kilometers. Yeah, I believe that's right. Anyway, it's really an impressive flight here. We are 5,963 days into the flight, about 16.3 years. Oxygen supply is still well over 10,000 days. And so, I'm going to start time warping a little bit more carefully. I'm going to zoom in on map. And our next orbit to cross will be that of Earth. And another thing I'm going to do, I'm going to set something up here in Burn Time Calculator. Time to periapsis. And the DV to put in, I'm going to give it 5515. Perhaps that should have been 515515 000? No. Well, I'm still getting it wrong because the post-burn vehicle mass is negative, and that just can't be right, so. Five, 515. Okay. km per second. Okay, there we go. So I've got that amount of DV set in, and I'm arming it for a burn prograde at periapsis. And as we approach periapsis, I'm going to engage the prograde autopilot, because by then we'll be using normal time and moving like crazy. And so now let's go ahead and reset prograde just to keep us pointed in that direction. Turn that off, do kill rotate, and begin time warping. And we'll go back to orbit MFD. And you can see how fast the altitude is counting down now. Which is why I'm going to have to stop using 100,000x real soon. In fact, I think now I should switch down to 10,000x, because given this velocity, it's too easy to overshoot. We'll hit 100,000 a few times for a little bit. And now let's back it off. We are now crossing the orbit of Earth. Let's target the next, which would be Venus, and continue. And I think 10,000x, a little burst of 100,000, and then we'll stick with 10,000 from there on out. Switching to 10,000. Actually, stop going back to normal time. We have crossed the orbit of Venus. Now, the orbit of Mercury. Things are getting really sticky here. Time acceleration. This won't take long. A little bit of 10,000. Note this number is counting down fast. I don't dare use 100,000x anymore. Too easy to overshoot. See on IMFD we're crossing into the orbit of, approaching the orbit of Mercury. PEA and PEV are holding steady. We're starting to see the curve of our orbit as it passes around the Sun. The Sun is becoming visibly large in the sky ahead of us. I don't suppose we need planetarium mode anymore. .66 kilometers per second and accelerating. This is going to be cool. And all I have to do, control-wise, is to make sure that as we reach periapsis, the ship is facing prograde, so that burn time calculator can auto-burn the remainder of our fuel for one big push right as we hit periapsis. And our velocity immediately after that is going to be the prize winner. That's going to be the number I want to know. Backing off time acceleration down to 1000x. In fact, we can go no target on here, as Mercury is now irrelevant. We're fast approaching the Sun. It now dominates the sky in a big way. Backing off to 100x time acceleration. We get down to 10x, I'm going to hit prograde. Okay, that's still counting down. And it's armed for an automatic burn. Alright, looking good. Zooming in over here. And that's what our orbit is supposed to be doing around the Sun. A close approach and a serious boost right here at periapsis, where we're going to be slingshotting around the Sun. It's too bad Orbiter doesn't have other star systems, because this would be a way to get to one. Although granted, 100,000x time acceleration just wouldn't be enough. Back to 1,000x for a little while. Over 200 kilometers per second now. We're coming in close, fast. Now, if Orbiter simulated radiation damage and whatnot, the crew would be dead right now. Down to 10x. Okay, let's orient prograde. Let's go ahead and bring up burn time calculator on this side. Okay. I'm going to update the DV value to 5517 to reflect the increase in DV from the use of oxygen. Let's see, I'll look at this outside. It is just absolutely a glare and a half. Okay. We are 4,000 seconds from periapsis. Time warp a little bit of 100x. Velocity 430 and climbing. All right, here we go. We're less than 15 minutes from, right now, less than 15 minutes from periapsis. Moving at over 553 kilometers per second. And it won't be long before I have to switch down to 1x time acceleration. Burn time calculator is armed for an auto burn that will use up the last 5 km per second of fuel at periapsis, where it can do the most influence, where it can do the most, get the most results. And we'll see what our velocity is after that, slingshotting the Sun. Crazy, I know, and nobody would do a mission like this for real, but I just had to know. I really had to know. Okay. Less than 5 minutes from periapsis. The burn is going to start in less than 100 seconds now. I'll go back to real time at about 20 seconds. Okay, we are now on real time. 576.9 kilometers per second. And burning. Now accelerating. Eccentricity getting higher and higher. We are in a hyperbolic orbit around the Sun. There is certainly no return from this voyage. Okay, that's a little bit of 10x on the burn here. Don't seem to be accelerating that much.
Warning, main fuel low. System reset.
Almost out of fuel. Engine cutoff coming up. In 10 seconds.
Warning, main fuel depleted. System reset.
582.5 kilometers per second. That is truly awesome. And it's definitely enough. I do believe it's enough to get the ship out of the sphere of influence of the Sun, which is what this circle represents. Very interesting. That's pretty much what I wanted to find out, how fast you could get a ship going. And 582.2 kilometers per second is very impressive. I can think of a ship or two that might be able to do it faster. The Arrow Freighter and the Discovery 1, both having insane amounts of fuel. So I might try this again sometime, but there we go. One really insane flight. Even if I zoom way out, the Sun dominates totally. And in a real flight like this, this ship would have to have some incredible radiation shielding to make it survivable at all. So ends an insane kind of flight, but a fun flight just the same. And where our pilot will end up, nobody knows. But set some records for certain. Thanks for watching. Take it easy. I'm out of here.